Hello everyone, Assalamualaikum warahmatullahi wabarakatuh, and good day to every one of you. Welcome to my video. So basically this is a continuation of a lecture video on chapter 4, which is induction motor. Okay, and thus in this video we're going to continue our topics on subtopic equivalent circuit model of the induction motor. Okay, so let's move to the topics of today, which is equivalent circuit model. So basically this is the equivalent circuit model for the induction motor. Okay, so this is the stator circuit and this is your rotor circuit. Alright, so the per phase equivalent circuit of the three-phase induction motor is actually similar to the single phase of equivalent circuit of transformer. Okay, so if you still remember, for the transformer you have a primary winding and also you have a secondary winding. Okay, so in the middle we have a mutual magnet coupling here. Okay, so it's actually similar to the transformer, but the only difference here is the secondary winding of the induction motor is short circuit here. Okay, you short circuit here. But if you still remember, for the transformer, you didn't short circuit at the secondary winding, but you connect it to the output load. Alright. Okay, so basically based on the circuit, the ES, which is supply, the E supply per phase. Okay, so this is the per phase voltage. Okay, so basically when the question gives you the value of V line to line, you need to convert to the per phase first. Okay, so this is the terminal per phase terminal voltage. Okay, so R1 represents the per phase stator winding resistor. Okay, so this is the per phase stator leakage inductance. Okay, and then for the RC represent the per phase stator core loss resistance. Okay, so XM represent the per phase stator magnetizing inductance. Okay, so this is the stator circuit. Okay, for the rotor circuit, so this one represent the per phase rotor circuit resistance. Okay, and then this represent per phase rotor leakage inductance. Okay, alright. Okay, so basically the equivalent circuit model for the induction motor can be simplified by referring to the stator of the induction motor. So in this case, meaning that we refer to the primary side. Okay, so now you have the R rotor will be equal to R prime over S. Okay, so X rotor will be equal to X prime. And then the I rotor is I prime. Okay, so you can also write it down as per R prime is equal to R2. Okay, X R prime is equal to X2 and I R prime is equal to I2. Okay, so this is the simplified circuit where you refer your rotor circuit to the stator side. Okay, and then this one you just remain at the stator part. Okay, alright, where in this case from the circuit you can obtain the value of I1 will be equal to the voltage supply here, okay, ES phase divided by R1 plus X1, okay, in series with RC parallel with JXM parallel with the R2 divided by S parallel with XR X2. Okay, so in this case, here and here, you just put it in terms of series. Okay, so here parallel with this and parallel with this. Okay, after you simplify this, then only you put it series with R1 and also X1. Okay, so the whole R equivalent, the whole Z equivalent, you just divide by the ES phase and then you can get the value of I1. Okay. Okay, next, there are other way on how you represent your equivalent circuit of the induction motor. Okay, so the circuit can also be simplified to another version. We call it as a approximate equivalent circuit. Okay, so this one also we refer to the stator, but the only difference is the RC and XM we move to the terminal voltage. Okay, we move to the front. Okay. So the purpose of moving this to the front is to allow a simple calculation to be performed to calculate the currents in the circuit. Alright. So this one we call as an approximate equivalent circuit. Okay, so this is actually different from the previous circuit. Okay, so in this one, when you find the value of, in order to find the value of I1, okay, you need to simplify the, you need to calculate the value of the Z equivalent, where this element is parallel with this and parallel with this, then only in series with this, then only you can find the value of I1. Okay, and then the other way around on how to draw your circuit is using the approximate equivalent circuit, just like this. Okay, where you move the RC and also XM to the front. Okay, so in this case, what you can obtain is, here is the I2, okay, here is the I1, here is I0. So how to find the value of I1? I1 will be equal to I0 plus I2. Okay, you can just perform the Kirchhoff current law. Okay, so in order to find the value of I2, you can apply the normal Kirchhoff voltage law. Okay, so I2 will be equal to the voltage supply, the voltage so the per phase terminal voltage here, E as phase, divided by R1 plus R2 over S plus JX1 plus JX2. Okay, so this is the value of I2. Okay, and then next we need to find the value of IC and also IM, where I0 is equal to IC plus IM. So in this case, the voltage supply across the RC will be equal to the voltage supply across the XM here. So in this case, IC will be equal to, the voltage here is the E as phase divided by RC. Okay, for IM will be equal to E as phase divided by XM, GXM. Okay, so once you find the value of IC plus IM is equal to I0, then only you can find the value of I1. I1 is equal to I0 plus I2. Alright, so that is how you find the value of I by using the approximate equivalent circuit. Alright, so we will see in details on how to use all this formula in the next following example. Okay, for example 4.3, the question here, you have a 3-phase, 100 horsepower, 400 volt, 50 Hz 6-pole, Y-connected squirrel cage induction motor. Has the following parameter that refer to the stator part. Okay, so this is the value of parameter in the equivalent circuit model. Okay, so you have a R1. R2 is actually the rotor side that refer to the stator, X2, and also you have a XM. Okay, and then in this case, you see the value given is 400 volt, is actually the V line to line. Okay, alright. So using the approximate equivalent circuit, find the following at 500 slip. Okay, so take note here, you need to use the approximate equivalent circuit in order to represent all this value. Okay, so you need to find the value of speed, then you need to find the value of line current and also the power factor. Okay, alright, so first of all, we need to find the value of speed. Speed in this case, we need to find the NR actually. Okay, so NS is given by 120 multiplied with frequency divided by pole. From the question, the frequency is 60 Hz and the pole is 6, so you get the synchronous speed is 1200 RPM. Okay, and then S is given by 500, S is given by 5%. So how to find the speed of the rotor is actually the NR. So you know the formula is S is equal to NS minus NR divided by NS. Okay, so you can find the value of NR now. Okay, so NR is equal to 1200 multiplied with 0.05. Okay, and then 1200 minus these two. Okay, and then you get the rotor speed is equal to 1140 RPM. Okay, alright. For the line current, okay, so you need to use the approximate equivalent circuit. So you just draw the circuit first. Okay, and then in this case, the question gives you the value of V line to line, which is the 400 volt. So you need to find the E as phase. So E as phase will be equal to 400 divided by square root 3. So you get 230.94 volt. Alright. And then you need to find the line current, which is the I1. Okay. So in this case, RC is not given, right? So you can just consider IC is equal to 0 lah, alright? Okay, so since IC is 0, so I naught will be equal to IM. Okay, I naught will be equal to IM. So the voltage here divided by JXM will be equal to the IM. Okay, and then after that, you need to find the value of I2. So here is the I2. I2 is the voltage supply here, E as phase divided by R1 plus JX1 plus R2 divided by S plus JX2. Okay, alright, so you just substitute all this value into here. Finally, you get I2 is equal to 104.2 angle of negative 23.96 ampere. Okay, so once you find the value of I2, I naught is equal to IM, then you can find your I1, which is your line current. So I1 is equal to I2 plus I naught. So you just add on these two numbers, 1 and 2. So finally, I1, which is the line current, is given by 115.52 angle of negative 34.48 degree ampere. Okay, alright, so this is your line current. Okay, next you need to find the power factor. So power factor will be cos theta. So in this case, theta represents the angle of the current between the current and the voltage. Okay, so the angle is 34.48. So you get negative 0.824. So since the value of current, the angle is negative, okay, meaning that the I lags the V, so your power factor is lagging. Alright? Okay, so that is how you solve the question that related to the equivalent circuit model based on the approximate equivalent circuit. Okay, so I think that's all for now. Thank you for your time. Thank you for watching my video. I'll see you in my next video. Okay, bye.